Hello, everyone. Thank you for coming today. It's a pleasure for our company to present our latest solution to you. Today, I will introduce the GUI demo application. Today's introduction mainly includes the following topics. First, the software and hardware environment will be introduced. Then, the software compilation and download and experimental verification will be introduced. Finally, the important codes will be briefly introduced. This report is mainly introductory content. For the technical details, you can learn more about them through the SDK online documentation. GUI demo is a simple example that demonstrates how to use a GUI, implementing a basic UI design with a touchpad as the input device. The GUI demo supports the RTL87X3E, RTL87X3D, and RTL87X3EP development kits. To quickly build a development environment, please refer to the SDK online documentation. The default supported touch driver IC model for GUI demo is CHSC5816, and the default supported display driver IC model is SH8601Z. For convenience in testing the touchpad and LCD, we have developed an adapter board. Simply plug the adapter board into the card slot of the EVB, and it is possible to test and use the touchpad and LCD. Here we show the EVB and screen adapter board of RTL87X3E and RTL87X3EP. Please refer to the SDK online documentation for the mapping relationship between the touchpad or LCD and the EVB pins. Here we show the EVB and screen adapter board of RTL87X3D. Please refer to the SDK online documentation for the mapping relationship between the touchpad or LCD and the EVB pins. SDK provides image conversion tools that facilitate the conversion of images, such as JPG, PNG, BMP, into burnable bin files. For font resource conversion, consult with FAE to address the requirements. To learn more about the usage guide of this tool, please refer to the SDK online documentation. When the image and font resources are generated as binary files, you can use the packaging tool to convert them into the final user data binary file. The packaging tool is located in the SRC App Panel Application Root Image directory. To learn more about the usage of this tool, please refer to the SDK online documentation. You can configure the LCD device and touchpad used by the GUI demo application by modifying the macros Target LCD device and Target Touch device. The supported LCD devices and touchpad for the GUI demo are shown in the table. For other function configurations in the GUI demo, please refer to the SDK online documentation. The following is an introduction to the compilation and download methods of GUI demo. Taking the GUI demo of RTL87X3E as an example. First, open the GUI demo project file of RTL87X3E, then select and compile the corresponding target. When the compilation is successful, the app bin file will be generated. Download the app bin and resource bin to the EVB board, and finally press the reset button, and the GUI demo application will start running. For detailed steps, please refer to the SDK online documentation. Next, we will introduce the experimental verification of the GUI demo application. Press the reset button on the EVB board, and the demo image will be displayed on the LCD immediately. You can switch the demo image by sliding left or right on the LCD. The GUI demo project is located in the board EVB GUI demo directory. The application source code is located in the SRC App Panel directory, and the GUI source code is located in the SRC Sample GUI directory. The structure of the GUI demo project is shown in the figure. This section will introduce some of the source code used in this project application. When the application is powered on or the chip is reset, the main function is called. In the main function, the function app.io resource request init is first called to request the DMA channel used for LCD screen refreshing. Next, the function app system clock init is called to configure the system clock. Then, the function app components init is called to initialize the LCD and touch devices. Finally, the function app task init is called to initialize the GUI server. To run the GUI on SoC, it is necessary to increase the CPU frequency to at least 100 MHz, and the SPIC must be set to 4-bit mode with a 160 MHz clock source. If enabling the PSRAM, the clock of SPIC needs to be switched to at least 80 MHz. As shown in the figure, call the function PMCPUFREQ to set the CPU frequency. Call the function FMC flash try high speed mode to set the SPIC mode. Call the function FMC flash set SEQTRANS to set flash sequential transaction. Call the function FMC flash NOR clock switch to set the SPIC clock source. And call the function FMC PSRAM SPI clock switch to set the PSRAM clock. For more details, please refer to the SDK online documentation. Next, we will introduce the initialization of LCD and touch devices. First, configure the pins used by the LCD, then call the function drvlcdinit to initialize the LCD. After that, configure the pins used by the touch device, and finally call the function drvtouchInit to initialize the touch device. Below, we will take the screen with QSPI interface as an example to introduce how to adapt your own screen to the GUI demo project. Firstly, it is necessary to implement the screen initialization function and add it to the function rtklcdhalinit. The specific content of the initialization function is to send the screen initialization instruction to the screen through the QSPI interface. The screen initialization instruction is provided by the screen manufacturer. The implementation of this function can refer to the function sh8601a init of sh8601z. Next, it is necessary to implement the function for setting the screen column address and row address, and add this function to the function rtklcdhal window. The implementation of this function can refer to the function lcd sh8601a xpy 454 set window in sh8601z. If there are backlight control or other control pins on the screen, the initialization part of these pins needs to be added to the function lcdpad_init, and the initial state of these pins needs to be set in the function lcddriver_init. If these pins need to be set when the screen is turned off, the control of these pins needs to be added to the function rtklcdhalsetReset. There is control logic for the screen reset pin in the function lcddriver_init, and you can modify the timing of the reset pin according to the requirements of the screen used. Below, we will introduce how to adapt your touch device to the GUI demo project. Firstly, it is necessary to implement the touch device initialization function touchDriver_init. Then, it is necessary to implement the function touchReadKeyValue that reads the touch coordinate data. The implementation of touch device drivers can refer to the driver of CHSC5816. The GUI server and the UI design are initialized in the GUI main function at the entry of the app task. First, call the function GUI server init to initialize the GUI server, then call the function GUI app install to initialize and install the GUI app, and finally, call the function GUI app startup to start the GUI app.